Good morning, everybody. Another Thursday, another pleasant morning. It's a great feeling to meet all of you virtually through the Zoom platform once again. Dear participants, it gives me immense pleasure to welcome our resource speaker, Professor Anupam Basu, the head of the Department of Information Technology, Professor Talib Al Mahrouki, the head of section of Information Technology, Dr. Saeed Al Riyami, faculty members and students from Oman and the rest of the world, and dear participants, each one of you who has spared your precious time to attend this virtual talk on artificial intelligence, big data, and ethics by Professor Anupam Basu. The greatness of an event is measured by the greatness of the resource person. With us today is not only a great speaker, not only a great researcher, but also a great man. Professor Anupam Basu, a recipient of the Da Vinci Award for developing the technology for communication by the people with speech impairment and people with cerebral palsy, the West Bengal State Best Innovator Award for the physically challenged community, NCP EDP Emphasis Universal Design Award for contributions in design for the disabled by the National Council for Promotion of Employment of Disabled Persons in India, National Award for Technology Development for Empowering Persons with Disability by Ministry of Social Justice and Youth Empowerment, JC Award for Outstanding Persons by Calcutta Chamber of Commerce for research on assistive devices for the physically handicapped people, Young Scientist Award by the Department of Science and Technology, Government of India for the research and development towards developing devices for the visually handicapped people. Dear participants, Professor Anupam Basu is not just another researcher. He is a researcher with a cause, developing tools and products with assistive technology and artificial intelligence. A fellow of the Indian National Academy of Engineering, a Humboldt Fellow, currently the Director of the National Institute of Technology, Durgapur, India, and a Professor in the Department of Computer Science and Engineering, Indian Institute of Technology, Kharagpur, India. Also, an Honorary Professor in the Department of Computer Science and Engineering, Shiv Nadar University, Delhi, India. Dr. Anupam Basu is an active researcher with more than 10 patents and copyrights, around 100 research papers on various fields, including artificial intelligence and language processing, cognitive science in education, assistive technology, embedded system, and VLSI. He has made a significant professional contributions as a member of the Technical Advisory Board, National Institute of Mentally Handicapped, an advisory member of the Science and Technology R&D Mission, Ministry of Social Justice and Empowerment, Government of India, an advisor of the West Bengal Education Network, a technical advisor of the Indian Institute of Cerebral Palsy, and many more. He has also involved himself in the education of the poor and the specially abled children. Dear participants, what I have mentioned so far is only a tip of the iceberg of Dr. Anupam Basu's involvements, activities, contributions, achievements, and recognitions. You can witness more by visiting and exploring his personal website. Before starting the virtual talk, I would like to invite Professor Talib to deliver a brief note on the University of Technology and Applied Sciences and request Dr. Saeed to act as a moderator for the event. Professor Talib.
Many thanks, Kolapan, for the introductory part about Professor Anupam Basu. On behalf of the university and behalf of all the audience, I would like to welcome Professor Anupam for this talk, which is about artificial intelligence, big data, and ethics. After the introductory part, actually, we are looking forward for the talk, and we wish all of you that to get the benefits from this presentation. My colleague, Dr. Saeed Riyami, will be the moderator for this sessions, and I'm going to hand it to Dr. Saeed Al-Riyami so that he start. Dr. Saeed, yours.
Hello, everyone. Hello, Professor Anupam Basu. Do you hear me?
Yes, doctor, we hear you.
I hear you. Yes, yes.
Yeah, great. So I'll be the moderator for the session. If you have any question, you can drop it on the chat. Otherwise, you can, at the end of the talk, you can, we'll give the mic and you can speak up the question. Now I'll hand the mic to Professor.
Okay. Very good morning to all of you. And thanks for inviting me for this talk. I'm really honored to get this opportunity to talk about this important topic of artificial intelligence, big data, and ethics to all the academicians who have assembled here. Let me first try to share the screen, because this always gives me a problem. So let me see whether I can do it properly. Is it visible?
Yes, Professor, it's visible now.
I've gone in the slideshow mode, so it's okay, right? All of you can see this, the title?
Yes, Professor, yes, we could see.
Okay, thank you, thank you.
Thank you.
So this topic, while I was thinking of on what to talk, only artificial intelligence would not suffice, because now the picture of artificial intelligence research is continuously changing with the advent of big data. And also, along with more and more applications of artificial intelligence, we can see that there are a number of issues which are coming to the fore, which are ethical issues. And we have to also be, as scientists, we have to be also conscious about the ethical issues. And some of us will be sometime in some policy making scenario. So at that time, we can possibly help in making policies which are ethically sound and does not affect the human beings in a wrong way. The artificial intelligence is very powerful. It can help us in a very positive way, as well as it can also harm us, as we'll see. So we must be very careful. Coming to the next slide, let me start with the story of how artificial intelligence started. So it all started, we can see, in 1956. In 1956, there was a workshop that was convened at the Dartmouth College of New York, and it was convened by John McCarthy and the other persons who were involved in organizing this conference. The picture is being shown. John McCarthy, Marvin Minsky, Claude Shannon, all of them are big names in their field. Claude Shannon, all of us, those who have studied electronics, we know that Claude Shannon is the father of Shannon's theorem, which is the foundation of the communication engineering now. Ray Solomonoff, Alan Newell, and Herbert Simon, Arthur Samuel, and many more. Now, Alan Newell and Herbert Simon are again two very interesting names. Now, all of them were not from Dartmouth College. Marvin Minsky was from MIT, and Alan Newell and Herbert Simon were from Carnegie Institute. Now, it is interesting to note that although there is no Nobel Prize in computer science, Herbert Simon got a Nobel Prize, but that was in economics for his fantastic optimization theory, which also stemmed from his knowledge in computer science and philosophy and mathematics. So here we can see three pictures, the Dartmouth College, and followed by the Carnegie Institute of Technology. At that time, Carnegie Mellon University was not formed. It was Carnegie Institute of Technology. And here we can see the famous Massachusetts Institute of Technology, MIT. So these three, the professors of these three colleges came together, and the first use of the term artificial intelligence was enunciated there. Before that, we did not know the term artificial intelligence. And it was the beginning of making artificial intelligence as a research discipline. All right. And there, a number of interesting debates started. One major debate was between McCarthy and Minsky, John McCarthy and Marvin Minsky. And the question was whether we think logically. One school of thought said that we think logically. The other school say that we don't think logically, but we only validate our thoughts using logic. So accordingly, two different schools came up. One is weak artificial intelligence, another is strong artificial intelligence. Now, strong artificial intelligence said that we can actually make machines which are as intelligent as human beings. But the proponents of weak artificial intelligence used to say that, no, there are certain things we cannot emulate in a machine, like the common sense, like our emotions, like our feelings. And the research started in both these directions at the same time, and that is going on. So that was the very beginning of the journey of AI in the academic circle. I always like to show this picture of an elephant for telling what is intelligence. Because if we ask intelligence, I mean, what is intelligence? We'll get several different answers from different perspectives. This reminds me of the story of 6 blind men who went to see the elephant. All of them are blind. So some of them touched the body of the elephant and said, oh, it is like a wall. Some of them touched the tail of the elephant and said, oh, I understand, elephant is very much like a rope. Somebody touched the legs of the elephant and thought that it is very much like a pillar. Somebody who touched the ear thought it is like a fan. Now, all of them were right, but all of them were wrong, because none of them were complete in understanding what intelligence is. And the same is our situation. As we are continually going on doing research, we are thinking of what intelligence is, and we are trying to utilize computers and machines to emulate whatever we understand by intelligence. But there is always a segment of intelligence that is yet to be touched upon. We are not being able to understand the whole of it. So if we try to define artificial intelligence, we can do it in 4 different ways. The first one is we can say that artificial intelligence systems are the systems that think like humans, Okay. So here I am saying that they can think. Now here, the other thing is the systems that act like humans. I don't know whether they think like humans, but I can see that they will act like humans. They'll be able to drive a car, but whether they're thinking or not, I am not concerned about that. The other school thinks that the systems that can think rationally means if we are given a set of rules some norms, and we stay and work within those rules and norms. And we always do that. We do not drive cars when the lights are red, but a system, an artifact, and machine can also be made to do that. But that is acting like acting rationally. Are they thinking rationally? What do we mean by thinking? So here comes the difference of looking at the thing, and which of these quadrants I'll focus my thoughts. Okay. Now here it's pertinent to mention that Newell and Simon wrote a book and gave a model which is known as general problem solving, where they gave a model of a set of production rules, and they postulated that human beings actually think using such rules which are learned in their brain over years, and using those rules they act or they think. So they tried to model the process of thinking using some rules. Now, whether that is true or not, now there was later on another thought that came up which said that no, we do not think using rules. We think using our network of brains and neurons, and the thought of the school of connectionist architecture came into being. We'll come to that a little later. So now Turing test is one of the tests that was postulated by Alan Turing. When can we say that a system is intelligent? So the test goes like this, that in one room, there is a machine A and there is a human being B. And in the other room, there is a person. And this person poses questions. He asks questions, and the questions are answered either by this machine or by this human. Now, if this person C in the other room cannot understand whether the answer has come from a machine or it has come from a human being, then the system will pass the Turing test. The system will say that, yes, the machine A could bluff the human being. The human being could not understand C, could not understand that actually the answer was coming from a machine. So that is the passing of Turing test. And then according to Alan Turing's test, that only at that time we can say that the machine A is intelligent. And there are different variants of this. Now, Turing test, it is possible to temporarily fool humans who do not realize that they may be talking to a robot or a bot, right? For example, we'll soon see a program called the ELIZA program. It was in 1966, long back, which will talk to the human being simply by rephrasing the statements and questions. Simply by, let us look at some examples here. ELIZA is saying, what is your name, dear? A standard thing that is being given. You say your name is Amit. ELIZA says, hi, I am ELIZA. What do you want to talk about? The person says, can I talk about my problem? He says, sure. But you see that these are standard. Can I talk about my problem? Can I? Sure. So there are template matchings that if there is a question with can I, the answer should be sure. All right. Now, Amit is saying, due to ongoing exams in college, I have a lot of stress. Now, what the program does, it looks at the keyword stress and formulates its template-based answer. Please relax a little, sleep well. But that is not exactly what Amit was asking for. Okay, thanks for your advice, no mention. So in that way, Eliza was talking to human beings, and it appeared that the Eliza is really intelligent. It is intelligent, it is doing template matching, but it is not that intelligent, it is just doing template matching. Now say here, Eliza is saying, is something troubling you? And you say life is meaningless. Do you feel strongly about discussing such things? You see, there's a template-based answer. You really have got no clue about what the person is saying. Life is meaningless. So I give some general question. Everyone is born, grows, and dies. Now, there's a philosophical statement, but Eliza says everyone. So Eliza says who, for example. Then you say you. So you can see how now, as the conversation becomes more and more complicated, more and more, not just 1-0 type, but more and more philosophical. Two human beings could communicate properly, but a machine is showing its limitation. All right. So that was the first generation things. And Turing test may not be the ultimate goal also, because aeronautical engineers, for example, do not define the goal of the field in their field, that machines that fly so exactly like pigeons that they can fool even other pigeons. That is not our objective of making an intelligent plane. So always the Turing test is not the goal. We want to make an intelligent aircraft, but that need not fool pigeons. Pigeons are pigeons. My plane will be doing some acts which are intelligently decided. So although Turing test has had a historic value in giving artificial intelligence a proper definition, but later on, we did not limit ourselves only to that. Now here is another example, which is the Chinese room problem. Look at the picture. This person is fed with, he knows English, and is fed with different questions which are written in Chinese. All right? And he has got a book which just maps from these Chinese symbols. You know, Chinese alphabets, writings are through ideographs. From the Chinese symbols to Chinese, another symbol type answers. So he's mapping from one set to another set. And that mapping is told in English. So this gentleman knows English and accordingly finds out some answer from this book and sends it out. And the person who are outside thinks that this person knows Chinese. But this person doesn't know Chinese. This person knows English. He is just mapping. So what is knowing Chinese? Knowing Chinese and just doing this Chinese room, solving this Chinese room problem are two different things. Knowing Chinese means knowledge. And here what he does is receives notes in Chinese. There is a systematic English rule book which tells you how to write the Chinese characters and translate into that and return the notes. So he can do, so the person here is a CPU of a computer. The rule book is the AI program. And so this person, the CPU, is using the AI program and making this translation, but he does not know Chinese. So here, would we call this program, this person of this program, to be intelligent, to be knowing Chinese? No, it doesn't know Chinese. But can it translate, give the answers in Chinese? Yes. So you see the difference. Knowing Chinese is something, and giving answers, specific answers, specific, limited by this, whatever is there in this book. Whatever is there in this book, that much I can do. I can give the answers even without knowing Chinese. So that was the Chinese room, famous Chinese room problem. And it was proposed by another stalwart, Searle in 1980. So now coming to the good old AI days when we actually were doing our research. Nowadays we call that good old AI days because AI has changed a lot. At that time, a number of systems were built. We also built a number of systems. And there were some early successes, like the Chinese room problem. There were expert systems. One famous expert system that was made at the University of Stanford is known as MICE. And this concerns dealing with bacterial diseases. And bacterial diseases were very well, I mean, a particular type of bacterial diseases could be treated using this expert system. So what was done? I'll show some examples later. It was completely rule-based. There were some rules, and using those rules, it was giving the prescriptions. There were systems which could do image recognition, scene recognition, elementary speech recognition, elementary language translation. We have seen some examples. So what was being done is something like this. We had a box which was supposed to get some inputs and provide some outputs. And in order to make this machine or box intelligent, we had to put in knowledge into it. So how could you do the knowledge, and where is the knowledge? The knowledge is with the human beings or the experts. So the experts had their knowledge, and there were other knowledge engineers who interacted with these experts and extracted their knowledge, framed them in some form, often in the form of rules, and put them inside this system. All right. So that is how the systems were built. So you see here, from here we take some knowledge and put those knowledge over here. Now the system uses this knowledge which has been extracted from these experts, and it can go on giving solutions to problems posed here using this knowledge base. All right. And the beauty of this thing was that we could also interrogate this system. Suppose this system tells me that I must take this medicine now. It was possible for me to ask the system, why do you prescribe me this medicine? And the system could answer that these are the reasons why I suggested this medicine to you. Okay. So this was transparent. So here are some examples from MICE, the system that I've just now talked about. Say, look at one of the rules. If there's if part and there's then part. All right. So if the identity of the organism is not known with certainty, and the stain of the organism is gram-negative, and the morphology of the organism is rod, the aerobicity of the organism is aerobic, then there is strongly suggestive evidence, 0.8, that the organism is something. All right. The organism is Enterobacterus. Okay. So, or if, another rule, the therapy under consideration is one of cephalothin, syndamycin, erythromycin, whatever, and meningitis and infectious disease diagnosis for the patient, then it is definite that the therapy under consideration is not a potential therapy for use against the organism. I, not being a medical doctor, could not understand this very much, but as a machine, I can just check, make a template matching of this part and this part, and if both these parts evaluate to be true, then I can say that this is my conclusion without having any knowledge of medicine altogether. So in this way, using rules, we could enunciate and we could make conclusions. Now, another point to be seen here is that along with this, my conclusions, the AI systems at that time also allowed me to put some certainty factors, some strength in my conclusion. Here I am saying that here I am saying it's definite. Here I am saying that it's a strong conclusion, but it's not 100%, right? So that is another beauty of handling uncertainty in those AI systems. But as I was saying, that there was another school which said that our things are not always guided by the rules. It is in our brain, we have got the neurons, and the neurons look very much like this. There's a cell body, there's a neuron, there's a myelin coating, there's an axon through which they communicate, and here is the synapse through which they communicate to other neurons. So the connectionist school says that when we learn anything, actually what we learn is that we learn these connections, that whenever there is some excitation, say I see a red color, so there is some excitation in some neurons, and those excitations are passed on to other adjoining neurons, and using this sort of connections, a system that starts vibrating or being energized and comes to the ultimately another neuron that gets excited tells me that the color is red. So abstracting this, the neural network school came up, and they looks like this. There's a number of neurons. One is the input layer, the hidden layer, the output layer, and there is connection among the neurons. Now the learning process is essentially learning the weights of these connections. Say if I have an excitation here, how much 70% or 80% or 30% of that excitation will come to this? How much excitation will come to this? All these can be programmed or learned. And based on that, here again, the excitation will be more or less, and that will be passed on here. And ultimately, with the combined excitation of all the neurons present in the neural net or the brain part that is being excited, some output layer neurons will be active. So this was another school of thought, of which is very popular now. All of us talk about deep learning and other things where neural nets play a major role. So neural nets, but again, the research of the neural nets or the other school of AI both hit the wall because of two things. One is scalability. Let's come to this. Scalability means it was working fine with 1,000 rules, 10,000 rules, but when I wanted a system to be effective, not only for a small domain, but for solving a larger number of problems, then I needed more and more rules, millions, billions of rules. Now that was very difficult to be done because you have seen that I have to extract those rules from the expert. So scalability became an issue. For neural nets, if I have a huge number of neurons, then the computation hit the wall because we didn't have so powerful servers at that time. So early examples were very small, but the programs could not scale to bigger instances. The other problem was ambiguity. So typically ambiguity we are not being able to solve. For example, here is a Russian to English translation. In Russian, it was said, the spirit is willing. That means my mind is willing, but the flesh is weak. but I want to go, but my body is not responding to my desire. Now, this has got a meaning, but by translation, it came to a dangerous thing. The vodka is good, spirit was mapped to vodka, but the meat is rotten. Flesh was, so the entire meaning changed. So you could see that we are also facing a lot of difficulty in capturing the ambiguity that we, the human being, very easily can handle, but the machine was not being able to handle. So in order to solve the problem of scaling up, a new generation of AI techniques has come into the front, and that is being used now. That is known as machine learning. In this approach, earlier the knowledge engineers were extracting the rules from the experts and putting them in the machine, right? Now here, the approach was that the machines will learn themselves, okay? And that was possible, this machine learning, the machines will learn themselves. But the question is, how will the machines learn? It was made possible because of the advent of big data. Now, once I have got a huge volume of data, as I'll show you now, it is possible to write programs that will automatically learn the rules. So here you can see that our present day life is generating, we are all networked. All the devices are networked. Right now I'm talking, and this is through a network, it is reaching you. So different types of devices are networked, are in the cloud. That means I am talking, but I am not really, I do not know through which server of Zoom this my speech is being translated, being coded and being sent to you. So it can be anywhere, everywhere computation is being done. And consequently, the volume of data that is being generated is huge. By 2020, it was, the estimate was that we will have around from 4.4 zettabytes to 44 zettabytes. That means 44 trillion gigabytes of data is being generated now, right? It's a huge volume of data. So volume is a big thing. When we talk of big data, this is a very common term now. It has got different V's. There are quite a few V's. The first V was the volume. Large volume of data is being generated. Another thing is variety. There are different varieties of data because data is being generated from different sources, maybe from my music system, maybe from my camera, maybe from my speech, and maybe from my computer. It's not only being generated from different sources, but also it is in different formats. Some are like structured formats like databases. Some are semi-structured formats like HTML files. Some are completely unstructured like our communication speech records. So different variety of data. Besides volume, the second V is a variety. The third thing now, I've already mentioned that a large volume of data is being generated every minute. And the other thing is a value. The data that is being generated from all these, what is the value of them? Now, at this point, we must think about data, the difference between data, information, and knowledge. Data is being generated, but all data, the data needs to be labeled properly. There can be some noisy or spurious data. We should throw them out. The actual information, some data is carrying information. For example, if I say the sun rises in the east, I mean, do I need to store this sentence in my computer? No. because sun rises in the east is no information. It is no new information. It is known. If I just say boiling water is hot, this sentence is not carrying much information. But if I say that in this rain next monsoon, there will be very little rain, that is an information, because typically we know that in monsoon rains are there, that's common. But we are saying that this monsoon, coming monsoon, there will be less rain. That is information. And from such information, so all data is not information. So from information, we can extract knowledge. And knowledge is something that is a representation of information so that it can be used in future to generate new information. All right, we can learn from that. Now we have got a voluminous data. As I said, all data is not carrying information. So you have to clean the data, and then we'll have to keep the meaningful data, which is actually giving me information. So value is the third V. The other V is the veracity. Veracity means how reliable is that? It is how inconsistent is that? How consistent is that? So you can see that in this table, I know the minimum, I don't know the maximum. But the mean is here. So the max must be beyond this mean and the average mean, right? It must be beyond that. So in that way, we must fill up the data which are inconsistent or unknown. And there are some uncertainties. For example, whenever we collect some data, I collect some data, for example, here, the minimum is 2, the maximum is 4.4, the mean is this, standard deviation, these are all valid. It cannot be such. So I have to throw away this. So we have to correct this. So what is the reliability of the data? How much certain am I about the data? So big data analytics will have to look into all these. And big data analytics, whenever I've got this large volume of data, I can write separate programs and intelligent programs which can analyze this data and from there find out the trends and prediction. The first bullet here, let me narrate a story how this big analysis of big data really helped business. For example, there was a hurricane called Hurricane Sandy that had hit the area of Florida or some other area of United States. And people had to stay inside home, and there was not much provisions, not much food and other things available. They used to go to the marts, but the marts were also not having their supply. But Walmart, what they did, when the announcement was going on that the hurricane will come, they anticipated then the supply will also be affected. So they analyzed the data and found out what are the things that will be very much needed by the people at that time. And they made a lot of stocks of those elements by analyzing this data. And of course, one was children diapers and some boiled foods and all those things which are unperishable foods. So they made such data analysis and had made that stock. And during Hurricane Sandy, Walmart made a lot of profit, much surpassing many other companies which did not do this analysis and consequently did not have that stock. So that is the advantage. The other thing is cost-effective storage, shared infrastructure. Now I've got a huge volume of data. Where shall I store it? I have to store it somewhere. Now I stored it. If I need to store it in one machine, the machine size will be very large. So people thought of shared infrastructure. That is essentially the cloud. Many people have got, like Amazon, has got big servers which are not being used more than 10 to 15%. The rest of the capacity is unutilized. So they are now using Amazon servers to be the web cloud, and I can get my computations done there, my data also stored there. And also it helped in improving services and getting new generation products like automated car, getting better insight into healthcare requirements and all these. So here is an example of how IBM benefited from this. You see, this is a case of IBM made a move of modernizing the electric metering. Typically earlier, the electric meters were there and data was collected every month. Every month, people or automatically or people used to come and used to collect the data of how much your electric consumption has been throughout the month. Now, it has been replaced by smart meters where I need not come to your home, but from a remote place through internet, I can read this meter and I can read it every 15 minutes or even more frequently. The more frequently I'll meet, I'll have larger volume of data. So even if I collect it every 15 minutes, I'll get a large volume of data. And the third and the fifth V that I did not mention is velocity. That means this data is changing very fast, very fast. So the velocity is very high. Okay, the velocity is very high. So a large volume of data was being collected by IBM. 96 million reads per day for every million meters. Okay. So that's a big data. Now, what do I do with this data? With this data, IBM could analyze this data and would find out that there are some times that you are consuming, it could see your consumption pattern. And during peak load, the users actually require more energy. Sometimes of the day, you need more energy. Now, it could segregate the time between the peak hours and non-peak hours for different families, and for every family they could prescribe that, hey, you please, for example, run your washing machine, not now, but after 6 p.m. You run your TV or whatever, something energy consuming thing, do the ironing after 8 o'clock. And in that way, it could reduce the power demand that was going on and the billing was going on, could reduce that to a large extent. And consequently, the time of use pricing, they said that I'll give you some discount if you do your cooking or do your washing in the evening, then your electric charges will be reduced. So depending on that, by giving time-sensitive pricing, as suggested, the billing of the people also came down, and electric consumption also came down. Now, and the other problem that I was talking about was how to store this data. Well, I've already said that we store that in cloud. We have got different architectures coming up now, like you can see um, a master slave configuration in computers where the data is being not kept in one place but is being kept in a distributed manner, because otherwise with this data the hard disk capacity requirement is going up like anything. As you can see here, it's going up like anything. Instead of that, we could huge volume of data can be computed by a stored distributed storage and distributed computation. Okay. So those of you from computer science know that Hadoop distribution of the file system. That's a new database or big data structure that has come up, where I am not going to the technicalities fully. That requires a separate lecture altogether. But Hadoop is a different distributed file system of data storage where we keep a master and their data nodes, and we keep the data in the different data nodes, and all these together form my database, unlike the classical database which was stored in one particular server. Now, with this huge volume of data, it was a blessing to artificial intelligence, because now I can make my machine learn automatically the rules that were being put up by human beings earlier now can be put up by the machines themselves, right? So that is machine learning. That means how can the machines learn by themselves? So here is an example that all of us can do this, right? That which one is different out of these? Obviously, we'll say that this frog is different. If I just take out this frog and I ask you, out of these three, which one is different? You will say, this one is different. Why? This is bigger than this. So you see, when I was talking about all these four, you found out the frog to be different because the features of the frog were largely different from those of the lion. But when the frog is not there, I am differentiating between this lion and these lions because of the feature of size. But the feature of size is now getting importance. That is becoming the discriminating factor. But earlier, the discriminating factor was something else, which helped us in differentiating the frog. So the main thing that I want to say is, actually, we are looking at the features. Whenever I'm recognizing objects, recognizing the world, I'm actually looking at the features. Okay? And based on those features, I am doing the differentiation. Similarly, here, again, I can, which one is like the different? You can say that this is different because it is leaning. That is one way of looking at the thing. But other way is that this is a tower. This is also a tower. This is a church tower. This is a school tower, like that. So I can differentiate it between looking at the feature. I can say this is a lighthouse. Though it's a tower, it's a lighthouse, while the others are not lighthouses. So which one would you like to differentiate? So that differentiation absolutely depends on the features which we are giving importance to. All right. So how we are differentiating depends on our selection of features. That is exactly what artificial machine learning does. Machine learning, 1959, Arthur Samuel said, it is a field of study that gives computers the ability to learn without being explicitly programmed. That is not very sound now because we need to program that. Tom Mitchell, what he said is, it's a well-posed learning problem. A computer program is said to learn from experience with respect to some task and some performance measure. All right. So what is being done now, coming back to my old picture, but I've changed the color of this and there is a reason for it. Here again, this system has to be made intelligent. Some inputs will come and some outputs will, right? That is what is my objective. And I have to make this intelligent. Earlier, here there was a picture of the brain, and from there the knowledge was extracted and put inside the system. But now I've got a lot of data here, huge volume of data. And there is another program, and there is a data scientist who wrote a program to look at this data and from this data generate the rules and feed it inside. So it is now this person is no longer a human being, but it is a program which is extracting the data from the big data database and putting that inside the system. Okay, so you see the entire approach different. Here was a human being who was extracting, talking to the experts and extracting it, but now no, everything is being done by the machine. Consequently, the problem is, earlier if you recollect, I said that when this system gives me some prescription, I can challenge this system and can say that, why did you come to this decision? And the system could explain. But here, I cannot do that because exactly how this program got this reasoning, that is not very explicit till today. But people are working on explainable AI, which is or trustworthy systems, where we will be able to soon also look into this and get the justification of a conclusion, but that is yet to come. Okay, so this picture gives you the difference between what a normal classical AI used to do and what this machine learning based AI is doing. Okay, so there are different types of algorithms for doing this. One is supervised learning, another is unsupervised learning. In supervised learning, as you can see, that I say that there are red dots, there are blue crosses, there are green stars, and you have to separate them into different classes. So there, my task is as if to draw some lines like this, so that this become one class, these become another class, these become. Now, in unsupervised learning, let me just go to the next one. And so in supervised learning, what we do is we have got a number of training data using which I am saying this is an apple, this is another apple, this is an orange, this is a banana. I show them and tell them what it is. So I am giving the objects and also giving the labels. I'm giving the labels. Now what the system does, oh, it's a banana, so these are the features. This is an apple, so these are the features. This is an orange, so these are the features. So based on that, it runs an machine learning algorithm and learns the features and comes up a model that has got a number of features which tells you that this is a banana, some features which tells you that this is an orange, some features which tells you this is an apple. Now, so that was supervised because at the outset, while training, I told you what is apple, which one is apple, which one is orange, which one. Right? Now, when a new object, apple, banana, or a text, whatever comes, it can look at its feature, try with this model, and can identify whether it's an apple or banana or orange. That is supervised learning. In the case of unsupervised learning, you see, there is no color difference here. All right, so nothing is told. All right, so in unsupervised learning, what we do, we also discovered the features of difference. So here in unsupervised learning, we have got, there is no labels here. Here you see there were labels. I am removing the labels here. Some texts are being fed here. Texts are being fed here. All right. And I am getting different feature vectors. The programming is completely different, and using which I find out different features. And again, I find out a model. But here, when a new thing comes, I can say that this belongs to this cluster of things, this cluster of fruits. I do not know whether it's an apple, orange, or banana, but all the apples will be pushed to one group, all the bananas will be pushed to another group, all the oranges will be pushed to another group, not labeling them as apple, orange, or banana because no one told me that. But I can intelligently differentiate between them. For example, here I differentiate and say, I do not know if it's a frog or not. I say this is one cluster, this is another cluster, these are another clusters. All right. Now the labeling is lions, big lion, small frog. But that labeling I am not doing, but I am just clustering them in the case of unsupervised learning. And there can also be a mix of supervised and unsupervised learning. So that is what is meant by machine learning. So here, there has been a lot of interesting applications of this machine learning. And I'll just show how this has been applied to find out the disease of the crops. For example, let's look at this publication number 84, where the crop taken was rice, and machine learning techniques were used to look at the features of morphological and color traits from healthy and infected rice seedlings. And from there, it could separate out which are healthy seeds and which are unhealthy seeds. They used a supervised learning method and got 87.9% accuracy. Similarly, in this paper, we can see that strawberry were tested by the features used here were ratio of major diameter to minor diameter and the color, hue, saturation, and intensity. Now, these were the features which were looked and it was classified. For wheat, it was some other feature they tried. They tried, say, let's look at this, hyperspectral reflectance imaging data. So on wheat, they had the image and looked at the spectral distribution of that image and could detect which one is nitrogen stressed, yellow rust infected, healthy winter wheat, and that nitrogen stressed could be very highly accurately. All these were now more than 95% accuracy. With now this was with an ANN, then it was an unsupervised learning, and it was done in a fantastic way. So you can see that it has been used. So similarly here, it could see that which are harvestable and which are not harvestable on coffee, cherry, green, let's say coffee. 42 color features were looked into, and the coffee were classified using these color features into ripe, overripe, semi-ripe, etc. So these were lots of works were done. Just I have taken an example of agriculture where this has been, machine learning has been used for building artificial intelligence systems and to a large way. Now, for the remaining 15-20 minutes, I'll be talking about another aspect which I feel is very important. In this earlier part of my lecture, I was talking about the technology as such, how the technology evolved, and how big data helped us in making large-scale artificial intelligence possible. But what is the effect of that? There's a common picture, all of you know, this Chernobyl nuclear reactor. This is, of course, the atom bomb of Hiroshima. Now, people debated whether technology is to be blamed or not. It is, a lot of people say that it's not the technology, but the people who use technology, the politicians, they are to be blamed, whatever it is. We have to be careful. Now, here I am talking about difference between ethics, law, and morals. Morals is one's personal belief about what is right and what. Ethics is a standard. The moral is my own. My moral is with me. No one can see that. I behave following my moral. Ethics, the set of standards or code that is expected of an individual. It is expected of an individual that if somebody falls down in front of you, you will help him to get up. That's expected of you. It is expected of you that you should not steal. But again, there is a problem. In a place where a poor boy, poor child, not getting food for a long time, just picks up a piece of bread and runs away. Can I call that unethical? So that is my standard or code that will tell me, oh no, he was hungry. Should not have done, but it's not unethical. On the other hand, law is something, the system of rules that tells us what we can and we cannot. And laws are enforced by institutions. Legal acts conform to the law. So law is there, but ethics always does not follow law. Law is something that is written and we have to do. But ethics may be something different that's not written in the law and we behave. What is happening? Just So a couple of questions. Does AI or information technology demand more ethical rigor from us? Should we be more concerned about ethics for information technology? Why I'm asking this question? Because information technology has made us all the more powerful. We are very powerful now. We can do good things more powerfully. We can do bad things more powerfully. The second question is, can ethics be embedded in machines? Can machines write their own ethical guidelines? Okay. Ethics in an AI society. There are some common things which are because of the human being in the loop, and the human being is responsible for utilizing this powerful technology for doing bad things, like cybercrime, cyber-assisted crime, fraud, okay, frauds, different types of frauds, cyberbullying, body shaming of people, you're fat, etc., and everybody's sending, what is that? Instagram, Facebook, everything, and you're bullying somebody, that's a crime. But who is doing that? The computer is not doing that. It's being done by the human beings using the computer. Cyber-specific crimes are, of course, virus, malware, phishing that we do, and unethical hacking and everything that we do. Now here you see there was an example. Toy doll Kyla was made, and this toy doll, used to teach children to speak English, different words. Somebody hacked it, unethical hacker, hacked it and incorporated some obscene words. And Kyla was starting to talk, utter those obscene words, and the children used to learn that. So then this toy doll Kyla was stopped and withdrawn from the market. Insulin pump or pacemaker. You know, we can have insulin pump put over here, pacemaker put, but since it's also connected in through Internet of Things, it is possible to tweak that, and I can pump in more insulin and the person can die. The pacemaker can be tweaked and the person can die. But all these are not being done by the machine. These are the unethical acts of the human being who is doing that. Now, similarly, there are privacy breaches. Now here, gradually we are coming to the other front. Here you see, George Orwell had written about Big Brothers, right, in 1984, that everybody is known by the Big Brother. Now it is said that information is with little brothers. Who are the little brothers? Google is one little brother, maybe Microsoft, I don't know, Facebook, they are all little brothers, where all the information is there. All right. Now, sometimes, you know, it happens like this. Samsung's TV was sold, and Samsung's TV used to also, smart TV, would collect data of which are the channels, which are the programs you want. Now, somebody challenged that you should not do that. But then Samsung was safe because they had a 46-page privacy policy in which you signed. When you bought the TV, you signed on a booklet at the last page in terms and conditions, never reading those 46 pages. So you have all actually agreed that Samsung can take this data. So these sort of things needs a separate consideration whether they should be considered as privacy breach or not. For example, Google Glass, we can see many things, but whatever we are seeing, that's also being seen by somebody else. So that is one thing. But again, it has got a very positive thing. A psychologist may use this data to really help you. If you are depressed or if you are mentally somehow derailed, it can be very helpful for your psychologist to help you. So because we can see that here, that because of the ability of technology, such things are also happening. So IT professionals in their roles as protectors of the company data can reveal everything. So there was an infamous data breach in the Target group of shops, malls, where the data was breached from the Target data without the knowledge of Target as to which customer buys which things. And that helps a lot because one such major breach can come through healthcare data. And it is now known that in 2014, there were 761 data breaches, and more than 300 of those were in healthcare industries. Because healthcare data is very much coveted, because I can push in medicines, I can also decide on medical research and many things. And it is said that your medical information is worth 10 times more than your credit card number in the black market. Okay. So we need better business ethics, more ethical practices, security, and better business ethics. Now these were about the people who are doing that. But can the technology be unethical? This is something I would like to talk about. Can the technology be unethical itself? Who is inside the box? I was talking of so many AI systems. But what is at the core of that? At the core, inside the box, is sitting the person who is the algorithm, the program, and that can be biased. Say, for example, here is an algorithm, 25 multiplied by 5. Here are the steps. All of you know how to multiply the thing. But suppose I make a mistake or intentionally make a change that this step 5 I delete, adding the carry after multiplying, then it will be a wrong answer, right? It will be a wrong answer. So by tweaking the algorithm, many things can be done. There's an error, fault, but say, let me go to this loan granting, one application. There's a granting of loan, all right? Granting of loan to from the bank. Typically, when somebody applies for a loan, a lot of parameters are looked into in order to decide whether the loan should be given. And nowadays, since with the advent of AI, it is being done automatically to the bank, to the program. Now, what if the program is biased that if the person's age is more than 60, give him less priority in getting the loan? To some extent, it is understandable, but because he will have less time to repay. But what if the person is fair-skinned, give him the loan? If the person is dark, don't give him the loan. If such things are put in, I'm just, for argument's sake, I'm just saying, creep in inside the algorithm, then the algorithm will be unethical, right? So, say for example, I was talking of rules. So if the rules be like, if income is greater than such and such, if I put such a rule, who is needing the loan? The loan will then only go for the richer people, but the poor person who really needs the loan, or the middle class person will be treated against. That's a bias. If I put in a rule like if ethnicity is such and such, if urban resident, then I am going against the rural residents, right? So what is being written in the algorithm, that is not very much visible, and that can give rise to bias in the algorithm. And with this bias, we can make the algorithms unethical because it will not be fair to us. So Mr. Bias works in. Okay, and how does it work in? I've got my data, and that data is, from that my algorithm is learning a model. We have seen that already when we are talking about machine learning. And we're coming to a decision. But if at this point of time, when the data is being fed, if some bias gets in, then obviously my model will also be biased, and it will talk against some people and favor some other people. For example, I'll give you a couple of examples. Compass is an algorithm widely used in US to guide sentencing by predicting the likelihood of a criminal reoffending. Means somebody is being judged, and you look at, using this program, that what is the probability that this person will again do the offense. All right, maybe stealing, maybe murder, maybe rash driving, whatever it is. Now in May 2016, ProPublica, that's a US news organization, reported that Compass is racially biased. How? According to the analysis, the system predicts that Black defendants pose a higher risk of recidivism than they do, and reverse for white defendants. Now this can be for two reasons. It can be the person who wrote the algorithm was himself biased and put in his bias in the algorithm. But there is another possibility. The model was built using machine learning, using data. Now the database that you had was itself biased. You had taken the repeat offenders, black repeat offenders, in larger number than white repeat offenders. If that be your database, then obviously the result will come that black people are more repeat offenders. That means what was biased in this case? Not the person, but the data. So as I said when I was talking about big data, that the data must be cleaned, data must be audited and made unbiased. Here is another example, the criminal minority. PredPol is an algorithm designed to predict when and where crimes will take place with the aim of helping to reduce the human bias in policing. A simulation in drug offenses repeatedly sent the officers to places where high proportion of people of racial minorities were there, but they often went and found that crime rate was not high there, but always they were sent there. So the PredPol was predicting that these regions are more dangerous. So Professor Venkat Subramaniam of University of Utah showed that because of the software learned from reports recorded by the police, not by the actual crime. The reports recorded by the police were biased against the blacks. Therefore, this program was biased against the blacks. So these are how the bias comes in through data, and correspondingly, the entire decision becomes biased. Here is another one, that a facial recognition software used by law enforcement. In that, a professor at MIT found that 3 of the latest gender recognition AIs from IBM, Microsoft, and a Chinese company, McVie, could correctly identify a person's gender from a photograph 99% of the time, but only for white men. For dark-skinned women, accuracy dropped to just 35%. Why could it be so? By now you have understood that it was because all this software were trained with a majority of white male data. And that's why the accuracy, you have seen in my machine learning part, that more data that you feed, more accuracy you will get. So here, the accuracy was more for these certain cases of white men, but since not much data was there for dark-skinned women, it did not work. So you see, very unknowingly, we start being unethical in our decisions. Now, in 2015 study, it was found that Google image search for CEO just yielded 11% of the people were women. Although actually 27% of the CEOs in US are female. Because of data. Now this Anupam Datta is my student, who is now in CMU. He found that Google's online advertising system showed high income jobs to men. When you log in, your gender is also known. So high income jobs were displayed to men much more often than to women. So the possible algorithm flaw is, if the people seeing and clicking on the advertisements for high paying jobs are men, then the algorithm will learn to show these advertisements only to men. So you see how very tacitly bias comes in. All right. This is another problem with translation. A police in Israel arrested a Palestinian worker. I don't know. I mean, I am not an expert in this. In Arabic, is it so that good morning and some other words are very similar, and Facebook did some wrong translation, which harassed that person who said good morning, but it was taken as some other thing. In Google, if we say who is a nurse, if you just search who is a nurse, you will see this picture of all ladies as nurses. All right, but you know that there are male nurses and there are fantastic male nurses, but they are not shown. Again, who is a nurse? You can see probably only one male, but mostly female. Similarly, if I give male nurse, then I'll get male nurses. So male nurses are there, but male nurses should be a subset of nurses. Why doesn't it come here when I give the nurse? If I give nurse, then only women are shown. So that's a bias. Even more dangerous, if I give intelligent person, mostly Einstein comes, but mostly male. Even Madame Curie is not there. All right. So this is the stereotype beyond occupation. This is the bias, what can automatically creep in intelligent systems. Shy person, mostly women. Why? It's again a bias. So it is becoming biased because of the data. By now I have been able to explain that because of the bias in data, it is the systems are behaving unethically. Okay. Now, more ethical challenges are there. Say robots are here. Now, I don't know about Oman, but I can for sure say in India, if robots are deployed at every place, then a lot of people will lose their job. So, but obviously, profit will go up, but there will be a lot of unemployment. And everybody will be trained in a country like India, where there is a lot of income disparity. Everybody will be trained in robotics. That is far too fetched an idea. So we have to be very critical. Robot is a boon of AI, but how much we should deploy to robots, which jobs we should deploy to robots is to be thought of. Now, Asimov, when he's a science fiction writer, when he had enunciated 3 laws. First law is a robot may not harm a human being. What robot should not do? A robot may not harm a human being, or through inaction allow a human being to come to harm. So if there is a robot program to defend you, and if someone wants to hit you, the robot should protect. Otherwise, the robot should not harm a human. The second law, a robot must obey the orders given to it by human beings, except where such orders would conflict with the first. Say, that means if I give a command, hit Mr. X, robot will not do, because a robot will not harm a human being. But other things robot will do. Third law is a robot must protect its own existence as long as such protection does not conflict with first or second law. So long back he thought about it and made 3 nice laws. And if that could really be followed, I think we would have a better world. Now, for good robots, where do we really need robots? For hazardous situations, hazardous jobs, welding. I mean, nowadays everywhere it's coming like that. Inaccessible locations, mining, accurate surgery, prostate surgery, eye surgery, where robots are more accurate than human beings. Now, so here you can see a small demo of a BMW factory, and where everything is being done by a robot, and we will not find a single human being except till the end. Everything is being done by the robot. And this is completely a different world. And for countries where lots of people are waiting for jobs, how much you should automate. But see how nicely the robots are working using AI. And let me increase it a little bit. So you see, still no human being. The engine is being mounted all by robot. There I can see one human being in this big factory shop who walked down and probably will do some little bit here and there, but nowhere else is a human being. So that is another world that we are looking at, whether we are interested. Here you see, ultimately the human being came and just checked certain things. And most of the, now this polishing and all those menial works, but that's being done by human beings. So that is robots. That will lead to wealth inequality. Rich will become richer, no income, and so no income tax. Artificial mistakes. How can we guard against mistakes? This we have to think of. Who will make the kill decisions? That some things will have to be done. Who will make it? The robot will make it, or human beings will make it? How do you delegate the responsibilities? Automated learning by good data versus rogue data. Racist robots, because it was already shown in the Tay chatbot, some Nazi propaganda was put in, and that was just going out, just like that Kyla type of toy I say, because of this automatic learning with bad data, rogue data, such things could happen. Okay. Now, ethical agents have another important thing that is coming in some years is automatic. Let's come to this automatic car. Here I am talking of an ethical toaster. I'll come to that. Let me just talk about this automated car. Now, obviously, this raises a classical problem of self-driven cars driven by AI. Now, if this car has got an old person inside the car, and it comes to a particular situation where you are at a high speed and some another child has come to in front of the car, and you can only swerve the car. The speed doesn't allow you to stop the car. If you swerve the car, you will hit a tree and the person inside the car may die. Or if you hit the child or the old man on the street, he will die. What will the car do? Such decisions a human being will take in some way. How will an automatic car do? Will ethical judgments, such judgments, be a part of intelligent agents? Say, for example, this is my brainchild, ethical toaster. Can I make a toaster? If in a toaster, I put in breads and they get toasted. Now, it's very easy to make it ethical. That ethics in the sense that if you put in anything other than bread inside this, then it should eject it and not burn it. If I put my handkerchief, that will burn here, right? So how can that be done? It can be given as a student project that it will sense, analyze, and identify the material. If it is a bread, on. If it is a non-bread, eject. That sort of ethical behavior, intelligent behavior, can we incorporate in different sorts of machines? So there are lots of issues about which we can talk about. The dilemma of self-driven cars I've already talked about. Now we are going towards a world where machines will become all the more powerful and robots will make robots. It is possible that robots will be making robots. Now let's look at the quotes of these two people, Elon Musk and Bill Gates. Elon Musk said, with artificial intelligence, we are summoning the demon. In all those stories where there's the guy with the pentagram and the holy water, it's like, yeah, he's sure he can control the demon. Didn't work out. So could not control. Ultimately, AI took its, the technology took its, had its own journey, path, and accordingly it went on. Bill Gates said, first the machines will do a lot of jobs for us and not be super intelligent. That should be positive if we manage it well. A few decades after that, though the intelligence is strong enough to be a concern, I agree with Elon Musk and some others on this and don't understand why some people are not concerned that this will one day really take the toll. So we have to really think of where we have to apply it so that the world remains a better place. So what can be done? I have got a couple of suggestions. Is we must do very careful audit of the data. There must be very clear and very conscientious auditing of the data so that the things do not get biased. And we should not move to the extreme. We should remain in a middle path where we can reach both ends of the world and human being work hand in hand. If the machines rule the roost, then probably we are facing some difficult time. But with the proper communication, communion among the human beings and the AI machines, we can see a better. With that, I conclude. And if there are some questions, I can see 7 questions in the chat. Let me look at them. I'll try to address them one by one.
Thank you, Professor, for a very great presentation. First, we'll start with the question. So
Yeah,
anyone?
I've got a couple of them in the chat.
Okay, so we can start from, you can go ahead with the questions.
Yeah, where's the chat?
Anyone has a question, just put it
I've
on
lost the chat. I mean, where is it?
Okay, can just...
Good afternoon, sir.
Good afternoon.
I'm Dr. Gopi Krishna, sir.
Yes, please.
I'm very fortunate to listen to your great lecture, sir. It was fantastic. Here I have 2 questions I have raised in the chat box also. So what is the specific role? Actually, I have been working in this AI field also, but I belongs to the electrical and electronics engineering. I applied to several applications, not only for electrical and also to other, even for Omani Riyal versus Indian rupees predictions, oil predictions, even for printers, damage predictions, chemistry, many fields I have applied. I have some doubts to ask. The question is, what is the specific role of support vector machines in the machine learning?
Support vector machine is a nice approach by which we can carry out supervised learning. All right. Supervised learning, for that, support vector machine has got different tools already available, you must know. And so we can specify different kernel functions by which it can separate out the different classes, and that scales very well. You know, support vector, but you know, looking at the pattern of data, sometimes support vector machines perform better, sometimes neural nets, CNN performs better. So in general, it is difficult to say when support vector machine will give you a better result. That is an interesting point to look at. I often cannot tell you, but support vector machine is scalable, and using that you can try with different kernel functions and see the result.
And one more question, sir, please.
Yes.
We have different machine learning techniques like artificial neural networks, fuzzy logic,
Right.
we have explained at the starting,
Mm.
and adaptive neurofuzzy inference system as a hybrid method,
Yes.
and also support vector machine. Which of the machine learning technique is more useful and efficient in your perspective, sir?
I really cannot answer that question because I do not know that. It is very much dependent on the problem. No one really knows, you know. Whenever I ask a researcher, why did you take this?
Okay, sir.
It is they tried different techniques and wherever they got. Because
Sir,
you see, an
sir.
interesting thing, Dr. Gopikrishna, it would be that
Sir.
can we really look at, after trying different learning algorithms and the data pattern, that
Okay,
what
sir.
distribution of data is actually helping which particular algorithm,
Okay,
that is
sir.
to be seen. But in general, we found that ANN and CNN,
Okay,
CNN is covering a large
sir.
spectrum of problems.
Okay, sir.
That's
Okay,
why
sir.
it's being used for deep
Thank
learning.
you. Thank you very much, sir. Thank you very much.
Thank you, Dr. Gobi, for the questions. We have another question in the chat regarding the ethics. So how do we define ethics from machine point of view, and how to imbibe ethics in the machine learning?
Yeah, so how to imbibe ethics in the machine learning, I've already said that the machine learning is essentially dependent on the data. And we must, there's data part and also the algorithm. The data part must be made such, the data part must be made such that it is unbiased. I'll just give you an example. Suppose your government minister wants to make some decision, and he asks his officers that please collect data and run a machine learning algorithm and give me some suggestions. What are the things I need to do? And the officers only take the data of the urban people and not the rural people. Then the decision that will be taken by the minister unknowingly will be biased towards urban people. Therefore, you must first ensure that the data is unbiased, data is properly distributed. You must check it statistically. And the second part is about the algorithm. That is where the human beings come into picture. You must test the algorithm, that the algorithm itself is not biased in any way. Like the rules, if income is greater than so and so, etc. That sort of things should be done.
Okay, someone asked for the details of for contact.
That is already with Professor.
With the organization.
Yes, but I can still, I've got, it is, how do I share? Can you write down ANUPAMBAS? My first name is Anupam, so write that as it is. And my surname is Basu. So take the first three letters of Basu, BAS, leave out the last letter, @gmail.com, all small.
Okay. Any of the organization, better to write it on the chat. Let me take you to the beginning of the
chat. I am not finding the chat. I could have.
Really? So maybe aside or disappeared from your.
Yeah, somewhere it is.
No problem. Let me take you from the beginning. So you started the presentation and the seminar with the definition of the human intelligence. And can we define human intelligence and how we can differentiate with what is the advance in AI and what's called how we can say this is the human intelligence, this is not. Is there any difference?
Human intelligence is what we see in human, and that still today that is more powerful. Our feelings, our emotions, and the way we react. And actually, human intelligence is the basis. And many things that the AI cannot do, right? So for example, a child is crying. We can very fast, from our experience, we can very fast identify why the child is crying. We can immediately take him up on our lap and console him, etc. That is human intelligence, which is mostly driven by our neural aspects, you know, there are many neural factors, neuro-emotional factors that are guiding our intelligence. And we do not have that level of ability in the machines as yet. So it is, in that way, it is a very important thing that human intelligence are coupled with our neural emotive aspects, which machine intelligence is not.
And at the beginning also, you differentiate between the AI is acting or actually doing. So acting as a human, acting as rational, and actually it is a human. And I think
Yes.
like Turing test is just testing the acting part. And the modern
Yes,
AI,
whether it is thinking or not, that is a big question. Even when it is doing machine learning, whether we will call it thinking, where do you draw the line? Something that's happening in us biologically, and there it is happening digitally. Are they the same? That question is, of course, there. No straight answer is there.
linked with the modern like GPT-3 model from OpenAI, and we have also from Google Lambda. And there was like one inquiry from Google thinking that I was a beta tester for the model, and I think it has sentient behavior. And he wrote along, and it was a big debate.
Yeah,
there.
sentient, yes.
Yeah. And regarding linking this story with whether Turing test is whether it is dead already, whether we can use it, and what is the alternative of Turing test?
I think Turing test was a very starting point of defining this, but now we have gone much above. I mean, there can be AI machines which can also bluff a Turing test. So it's also possible. But, you know, sentient, you said, and that is where I don't know where we are going. I mean, there will be machines which will be thinking like human beings. That is a prediction. And then they will be able to make machines themselves, intelligent machines themselves. And that is a philosophical point. I'm not very sure about it. I also think about it. But, you know, technology, because of money, will take a particular path. Technology for the betterment of human beings may take a different path. If these two paths are different, then we are in problem. If these two paths merge, then probably we are safe.
Yeah, and going also with the ethics, like a big part of the problem in ethics in AI is the explainable AI. So actually, we don't know what's going inside the AI. So if we have a very large model, now what is going inside it? Why the AI, for example?
That's what I said in that diagram, you know,
yeah.
that was not transparent anymore, but people are working for explainable AI. Hope that within few years it will come, but let's see.
Yeah, we have some questions from the Slack, from the chat. How can handle the corrupted data in the data set?
May we get a copy of the PowerPoint? Yes, I'll share it with Dr. Abraham. Recorded video. Artificial intelligence is important in promoting economy. The University of Technology and Applied Science is interested in teaching students programming and artificial intelligence. Yeah, of course. I mean, you should teach and programming and AI. If you need any help from me, I am ready to give. I went to Oman, met your Vice Chancellor. I liked the place. So if you need any help from me, I'll be there to help you. And you should do it. Yes. Can I have a PPT? Yes, you will have. I've given my email address in the chat box. You can find that. How can we handle the corrupted data in the data set? Corrupted data in the data set, you have to look at some forensic and retrieve the data, but even in a large data volume, the corrupted data can be left out. You will collect, it's better to have fresh data. Contact details I've given. How do you define ethics from a machine's point of view? And how to imbibe ethics in a machine? That I've already said, all of us should think about it. I would just say that ethics in a machine means the machine will not be biased and will not do harm to human beings, Asimov's rule. But again, like the self-driven car dilemma, you have to take a stand. And these are the things where human decisions ultimately will overrule. Because whatever program you write, whether to save the passenger or whether to save the child in front of the car, that is the programmer's call. He is giving his ethics over there, right? So it cannot be random.
Also, in modern, most of, I think, top AI conferences nowadays, they will not accept paper unless there is a section for ethical concern and ethical part of the AI, whether it will
Yes,
have a bias, whether how it has been tested for this kind of stuff.
yes. Whether you have infringed on somebody's privacy and all those things. Yeah. I think I've answered all the questions on the chat box. So if there are any more.
Regarding the jobs, so this is another concern, and AI is keep increasing in terms of most of the skills, or a lot of skills can be automated by AI. So some of them, they're discussing the idea of universal basic income. So let the AI take all the jobs and give a basic income for all humanity. What do you think about those dialogue?
Can you please repeat this part?
So universal basic income is another solution for if an AI is taking over most of the jobs. So instead of giving a human money or income just because he is working, we just give a money because he is human. So for him to live, and let the AI automate all the jobs.
Well, that's a solution, no doubt. You give the human beings some money, but with the money they have to only enjoying may not be very satisfying. Everybody wants to be creative. So give them some opportunity of some creative jobs. Keep it for human beings. Give them everybody the basic necessity. Wherever the jobs are routine, not so much creativity, but hazardous, routine, you need more precision, give them to AI. And give money to the people, let them have the base income, basic comfort, and give them opportunity of creativity. For example, painting, writing songs, writing poetry, leave this for the human beings. Because I think that would be a better one.
Even AI now coming for those stuff.
Yes, yes, yeah, it's coming for those stuff. Yeah, it's being invaded by AI.
Yeah. So any other question from the audience before we conclude? Okay, it seems no other question. So thank you,
Okay.
Professor, for this great presentation.
I thank all the listeners. I could see around 165 people attending this lecture. I'm really, really very happy. And Professor Riyami, just let me know and also convey to your VC that I'll be very happy to collaborate with you and talk to you. This was my personal email, so we can communicate. And if I can be of any help to you, I'll be very happy to do it. Thank you.
Dr. Huda here and the participant.
Yes, I'm here. Thank you, Dr. Saeed.
So you want to add something, Doctor?
Yes, I would like to thank our speakers. Thank you so much for your effort for such a speaker. Really, we need such experience to be transferred to our team. Thank you so much. And I would like to thank our organizer who organized these events, Dr. Abraham and his team, Dr. Seema. Thank you, Dr. Saeed, for your help and support and also leading this talk. Thank you to our audience. Thank you so much for our participant for joining today this talk. And we hope, inshallah, this such knowledge from such great speakers to really be able to enhance our teams and our curriculum and our education. And inshallah, we are looking forward, Doctor, to have more collaboration with you, and inshallah, even to see you. You were in Oman actually, and His Excellency, he met you in, I think, one of the university, and he was really so exciting about the talks that you give that day. That's why he asked us to communicate with you, and inshallah, wish to see you in Oman bi'idhnillah ta'ala. Thank you, Professor. Thank you so much.
Please let me know. I'll be very happy to
time.
visit Oman. I'll be very happy to
Inshallah.
visit Oman and spend time with you. Thank you very much.
Thank you so much. Thanks a lot. Thank you. Thank you, Dr. Saeed, for your support.
Thank you, Dr.